There's a work out of Stanford and UC Berkeley on using reinforcement learning to actually fly model helicopter tricks.
Like what?
So it turns out that if you're flying a model helicopter, I've tried to do this, it turns out to be really hard to do. Part of it is you have to coordinate the blades and the blades and the blades. Yeah. Mm-hmm. And part of it is that you can do crazy things with helicopters if you know how to do it. You can make them fly upside down, you can make them swing back and forth, you can make them kind of roll over and over and over. You can do all sorts of really, well, I don't know, you can do all sorts of amazing things, but professional stunt flying helicopter people can do amazing things. What the reinforcement learning work was about is trying to get a system to learn to do those same kinds of tricks.
Huh, and they were able to do this with real helicopters or real model helicopters?
A real model helicopter, not a simulator, but an actual, mini helicopter.
Okay, so that's cool. So you sort of convinced me that burlap and repository, that's sort of a good, okay, I buy that. But I do want to point out something that you said that I thought was interesting. Right? You talked about simulators and that maybe what we really want to do is work in the real world. But it occurs to me that at least one of those examples, the simulator is the real world. So games, right? So if you have games like backgammon, if you have simulations that people actually interact with, then that is actually the real problem itself. That is the real world. If I'm playing Pac-Man and I've got a simulator for Pac-Man, that's the same thing as having Pac-Man. And if I can learn to play Pac-Man, I've learned to play Pac-Man. There's not really a simulator involved.
I would make a distinction between grid world type simulators where they were developed specifically for reinforcement learning researchers to work with versus, as you say, the kinds of simulators that people actually interact with when they're doing things like playing video games. And so video games actually is a really great intermediate step between real physical world stuff and things that can be run in simulation. And actually there's been some terrific work in that space.
Really? Like what?
Well, one of the things that I'm very excited about recently is a group called DeepMind, which, they're very good at naming things, have a system for actually doing what they call deep reinforcement learning, deep Q learning, where they are actually trying to learn behavior in Atari video games from the 80s, where they actually are using Atari emulator, the actual games as people actually played them, taking the information that's available on the screen as input and sending joystick commands as output and learning to play actually at the level of human players.
Wait, they're as good as human players?
They are as good on average as human players. And some of the games are actually much better than people. Games like Breakout, where you have to bounce a ball all around.
Okay.
And then there's other games where they're actually much, much worse than people. Games like Frostbite, where you have to jump around on a bunch of ice flows. It seems very difficult for the system to actually learn what to do in that game.
Okay, so their head's in an oven, their feet is in ice water, but on average, they're comfortable.
I see what you're saying. So your point is that it's not playing just like a person, it's playing better and worse than people. So on average, you can say that it's kind of playing like people.
Mm-hmm. But still, that's kind of cool.
I think it's really amazing. And I think it's that particular data set is itself really interesting because there's 40 some odd Atari video games that are all built into the same system. You can use the same inputs and the same outputs and the same learning algorithm, but you can put in different games to see what it will do.
Okay, so it is just like Weka and it's just like UCI, except here Weka is the burlap algorithms or whatever, reinforcement learning algorithms, and UCI, instead of being input-output pairs, are sort of the real world.
Yeah, and there's some work that's being done in collecting data from the real world. For example, medical diagnosis or online education.
I like that. We should do something with that.
for trying to figure out what the right way of interacting with people online is. People have collected some of that data and there's reinforcement learning algorithms that are being run on that data. It's not the full reinforcement learning problem because you don't actually, the learning system doesn't actually have to decide how to collect the data. It's already been collected for it. But it is really using real data and making decisions based on that. And I think that's a really promising direction for reinforcement learning to go in the future.
Okay, I like that. So I got two things out of that. The first thing is reinforcement learning really can be used in the real world. It has been, it can be, and there's a nice bright future for it. That's good. And the second thing is, I was right, there was a bunch of stuff we hadn't talked about in the class.
Okay, all right, that's a valid point.
Okay, was there anything else? You want to wrap up with anything?
Well, I feel like we should say maybe a little bit about the current directions and the future of reinforcement learning. So one of the things that I think is really neat is that it's having an impact not just on engineering and computer science, but also on the behavioral sciences and the neurosciences.
How so?
Well, so the sorts of things that we think about reinforcement learning being good for are an agent that's interacting with some environment, it's making decisions, it's trying to figure out what to do, it's trying to be happy, And so you could argue that animals and people are trying to do exactly those sorts of things, that we are reinforcement learners.
Sure, animals do it, people do it,
Yeah.
birds do it.
Educated fleas have been known to do reinforcement learning.
Right, okay.
And so the interesting thing about that is the neuroscientists, when they're trying to think about, okay, well, how can we understand the algorithms essentially that people are running, they're turning to the reinforcement learning field as a source of inspiration for the structure of the algorithms, how they can be set up, what sorts of things seem to work and not work, and they're actually looking for evidence of these in real brains.
Oh, I like that. I like that a lot. And you know what I really like about that? Is it takes us back to the beginning of the machine learning class, it takes us back to the beginning of the reinforcement learning class, where we try to emphasize the point that reinforcement learning is not just a set of algorithms, it's not just an approach, it's actually a way of thinking about problems. And so really this whole class has been about solving problems.
And I feel like we have solved some problems.
Great, I think that's a wonderful note to end things on. What do you think?
Yeah,
Okay.
no, I think this was really valuable. Thanks so much.
All right, well, thank you very much, Michael. I appreciate it, and I will see you in the next class. Bye.